Welcome to Module 5.4, the research process, identifying research aims and developing hypotheses. Why do we do research? It may seem silly to ask this question, but it's important to connect our work on research studies to the overall purpose of conducting nutrition research. Research is necessary to provide evidence for models and theories. We can often see and understand how different components of a theory or model are functioning together in the real world, but we need to provide scientific evidence to support this understanding and to create a foundation upon which we build knowledge in the field. As evidence builds, we can then begin to make evidence-based decisions rather than guessing at what interventions might work. This evidence base then allows us to create policies and structures that will address the nutritional requirements of the whole population. The research process requires us to be flexible. As we build evidence in an area, research questions may change, and the significance of certain research questions may grow more or less important. As we develop new measurements or methodological approaches, we may find that we can ask different research questions and test new hypotheses that we could not test before. New innovations and discoveries may, over time, make previous evidence and research a little less relevant. And within our own studies, we may find that changes in our study population require us to change our methodological approaches. For example, a study recruiting and interviewing people in person and taking a blood sample before the COVID pandemic may need to change to a telephone interview and forgo the blood sample. Without those biomarkers, you may not be able to test a certain hypothesis under a specific aim that requires a blood measurement of a micronutrient. To identify a research gap, you want to ask yourself the following questions before conducting a study. What is your general topic of interest? For example, the effect of diet on malnutrition in adults. From there, you want to think about what the exposure of interest is. Is it diet in general? Is it meat intake specifically? What is the outcome you're interested in? Anemia or some other measure of malnutrition? What is your population of interest? Is it women of childbearing age because you're interested in how anemia may affect the ability to conceive or the health of a fetus? And where will the data be coming from? Is it coming from a national survey? Do you have biological specimens? Will it come from a clinical population? You may not know initially the answers to all of these questions, but thinking through these will help you begin to frame what your research question will be. Once your general research interest is identified, you then have to identify gaps in the literature that your research can contribute to filling. Find the unexplored or underexplored areas that have opportunity for future research. And you do this through an extensive literature review of published articles and sometimes books in the topic. When you conduct this extensive literature review, you do this to understand what's already been done before. What do we know about a specific topic of interest? You can find gaps in the literature, what we don't know, and to support the importance and validity of the aims that we build around that research question. We want to reflect that the direction of the research that we're considering is thoughtful and coherent. Does it fit in with the research that has already been done? Are we making a giant leap from what is already known into something else? We want our research to fit logically with previous evidence, even if we want to ask an innovative question that might challenge the norm. We still want to be able to build our research on a foundation of previous evidence so that our research question will make sense. The literature review must include at least three main factors. One, the public health impact. 2, the physiology of the exposure-outcome relationship, and 3, the epidemiology of the exposure-outcome relationship. For public health impact, you want to provide current evidence on the prevalence or incidence of the outcome, particularly in your population of interest. Has the prevalence or incidence of the outcome changed over time? What are the risk factors of the outcome that you can find in the literature, specifically those that you're interested in or that are relevant for your population? What are the known mechanisms that link the exposure to the outcome? Focus specifically on evidence or models for the relationship between the exposure and outcome, not on one or the other. So you don't want to look at just predictors of the outcome or just the risk factor. You want to look at them together. Is there known physiology or behavior linking the exposure and outcome, or a sociostructural mechanism? What prior epidemiologic evidence supports your study? Is this already a well-studied area, or is there very little research here, and why? Is there surveillance of your particular exposure or outcome? What types of study designs have been used to look at this relationship? And how are those studies powered statistically? Often you might find conflicting evidence or variation in the rigor of existing studies. You should acknowledge this and use the evidence or lack of evidence to justify your position on the topic. You can ask yourself these questions as you conduct your literature review process to keep yourself on track. How is the evidence significant for the research that we want to conduct? How will the evidence support my research questions? Are the arguments and results clear? If not, what's missing and what potential arguments aren't addressed? Is there evidence related to our specific topic? Is that evidence current? Are the approaches current? If not, are there better ones? If you keep in mind these questions, follow a systematic process, and summarize the findings and questions that are raised during the process, you will have the foundation of an excellent background for your research. Now it's time to determine a research question. The research question that you write must address a problem that needs to be solved. The question must be clear and understandable to others. When you write the question, you don't want people to be confused about what you're trying to study or understand. It also has to be researchable. The study must be able to address the question through data collection and a methodological approach. It can't be abstract or be something that we don't yet have a way of measuring. Sometimes you may find a measurable representation of your abstract concept. For example, when I was a student, I was very interested in the idea of powerlessness on a community level. What made some communities seem powerless to change the circumstances of the community and others not? Then I discovered measures of social capital in communities, and that realized that this was kind of a way of defining an abstract concept that I couldn't previously measure. So there must be some kind of preliminary evidence that supports your research question. It does not mean that you have to have evidence specifically supporting your exact hypothesis or why would you be doing the study, but you just need to lay a foundation of evidence upon which you can build your research question. The specific aims are a list of tasks that as researchers we propose to achieve in our research. And this is really a critical part of the study. When we are writing a study proposal, the specific aims page or the description of the specific aims are truly the center point of our study. It brings to the forefront the scientific importance and impact of the study and lets the reader know exactly what we're going to do. It must be clear, easy to read, and give the overall sense of what the study is about and what the approach will be. In writing specific aims, you must be concise but clear enough to understand what is the exposure, the outcome, and the population of the study. For example, let's read this aim. Compare the association between appropriate infant and child feeding practices and the presence of stunting in children less than 5 years by Lao PDR province. What is the exposure? It's infant and child feeding practices. And what is the outcome? The presence of stunting. And what's the population of study? Children less than 5 years old. And in this specific aim, we're saying we want to compare this relationship by Lao PDR province. So that tells us that we're expecting that there might be a difference in the relationship of infant and child feeding practices and stunting that differs by province. So the specific aims must also be realistic to be completed in the available time. You are not going to measure stunting in all children less than 5 years old in every province in Laos. You may take a sample of 25 children in each of 8 selected villages or cities from each province, say over a 2-year data collection period. But that detailed information may fit in your aim or hypothesis, but it may also come a little bit later in your description of your approach. Saying children less than 5 years by Lao PDR province gives us enough information to know what you're doing, and then later we can go into details about how we're going to achieve this aim. Aims must be achievable. The study must have the resources that are required to achieve the aims. For example, for our previous aim, the example we just used, we can't determine stunting without having measuring boards to measure height in children. And if we don't have enough measuring boards, or we don't have enough staff to go out to each of the villages or cities that we intend to go to in each province, we may not be able to achieve the aims in the stated period of time. The specific aims must also be measurable. Avoid vague terms such as bring or show. Instead, use strong, measurable terms such as quantify, estimate, compare, or evaluate. You can even have more specific terms than those, but they're good examples to start with. Avoid interdependent aims. What that means is to avoid that your first aim would be to develop an intervention or a method or answer a question that is needed for any subsequent aims. This can be really tricky sometimes, particularly in intervention or methodological research. So for example, if your first aim is to develop a validated new food frequency questionnaire for the Laos population, you can't have your second specific aim be to evaluate the dietary patterns of the Laos population with this new validated food frequency questionnaire. Because if you are unable to develop a validated new food frequency questionnaire, then you can't use it to evaluate dietary patterns. You would need a second study to do the evaluation of dietary patterns. An exception to this may be when you're conducting usability or user experience research with a new method. You have to be able to show that you can conduct any of your aims even if the other aims fail. All specific aims must be accompanied with a hypothesis and must be supported by previous evidence. Not everyone provides a hypothesis with each specific aim, but it really is the gold standard of writing aims, and proposal reviewers want to see your hypotheses. What is the hypothesis? The hypothesis states the relationship that we expect to observe in our study. The hypotheses show indirectly the overall impact that our study could have. If you hypothesize that increasing access to green vegetables in schools will decrease anemia in children, you are essentially saying that if your research is conducted, and you can reject your null hypothesis, you can potentially decrease anemia in children, at least children that your study can generalize to. You may have just an example hypothesis for a specific aim. If your specific aim might have multiple hypotheses within it or is looking at multiple variables, and you're not going to write them all out on your specific aims page. So hypotheses formulation relies mainly on a quality literature review. The rationale must be logical, supported with previous evidence, and the expectations must be reasonable. In writing hypotheses, you want to clarify the variables of interest. Your exposure variable, which can be a risk factor or a protective factor, or any factor that serves as an exposure or independent variable. For example, you may look at micronutrient intake, access to vegetables in schools, breastfeeding, or level of education of your participants as exposures. The outcome variable or dependent variable is the disease or health-related behavior or outcome of interest. For example, maybe anemia, stunting, underweight, or infant mortality. And to be clear, any of the exposure variables that are listed here, like micronutrient intake, could also be an outcome variable in a different hypothesis. None of these factors are always an exposure, always an outcome. They're just designated as the exposure and outcome variable in your hypotheses for your specific aim for your research question. Then you want to indicate the direction of the relationship that you expect. Positive or negative? Is it direct or indirect? For example, you may want to look at the relationship between maternal education and stunting in children. You may hypothesize that more years of maternal education will be associated with lower incidence of stunting in children. And that's an indirect relationship, right? As maternal education increases, perhaps stunting decreases. You may have a direct correlation between the number of meals in schools that include vegetables and levels of vitamin A in school children. Maybe it's a dose-response relationship you want to define, or maybe it's just a yes-no, school has vegetables or doesn't. But defining this says what you think the relationship is, what you expect to happen. There'll be a positive association between maternal access nutritional supplements and exclusive breastfeeding of infants. So here you may hypothesize that if you're able to provide mothers with nutritional supplements, they may be more likely to exclusively breastfeed their infants for the appropriate amount of time. Hypotheses should follow a logical direction, and exposure will be named before the outcome. In this example, there will be an inverse association between access to clean water and the risk of wasting. So have access to clean water as your exposure and wasting as your outcome. It's logical to write about the exposure first and then the outcome. The exposed and unexposed groups should be well defined. For example, children without access to clean water in their home will have an increased risk of wasting compared to children with access to clean water in their home. It is so important to always include the comparison group. You want to make sure you're not saying children without access to clean water will have an increased risk of wasting, period. Because that leaves you wondering, will have an increased risk over whom or compared to whom? So you have to make sure to include your comparison group. Reference the study population, particularly if it is a restricted or understudied study population, or if it's a representative sample. So your restrictions could include sex or gender, age, geographic location, diagnoses of certain chronic diseases. You may only want children of a certain age and gender in your particular study, and that's fine. You just have to define and make clear who that is. The example here is among children who attend school in urban areas of Laos. there is a positive relationship between vegetable consumption and healthy BMI. So you aren't saying it has to be children of a certain gender or even of a certain age. In fact, this may need to be a little more specific about the age range or type of school. But you're just saying that children who attend school in urban areas of Laos. So again, there's more you could define in this hypothesis, but it's at least telling you who your population is. Nonetheless, it's important to consider that on occasions, highlighting the group is not useful or could reduce the impact of the study. For example, if you're taking a convenience sample, you may not want to put that in your hypothesis. It may be that you can't conduct your study without using a convenience sample, or that's all that you can do with the resources that you have, and that is okay. But you may not highlight that in your hypothesis that your sample is a convenience sample. Hypotheses must be measurable but concise, include details, but balance the details with wordiness. So household income will be inversely associated with underweight. That's concise, but if you say income will affect underweight, that's too vague, and affect doesn't tell us the direction of the relationship. But you also don't want it to be so wordy or have so much detail that it's difficult to follow. Precision does not require specific predictions either. So your hypothesis should state the direction of the effect, but you don't need specific numbers. If you're too precise, your hypotheses will easily fail. For example, people who have a higher saturated fat intake will have a 55% higher risk of atherosclerosis than people with lower saturated fat intake. You may not want to include the 55% because that's very, very specific, and you may not be able to estimate with that level of accuracy, and you might also just be really far off. Hypotheses should use a neutral description. Avoid using any kind of valued terms such as good, better, bad, benefit. You don't want to say bad dietary patterns will affect the health of workers. You may say dietary patterns high in animal fat and processed sugars will negatively affect the health of workers, and then specify how you're defining health. Here's an example. We want to make sure to give you some examples that are most relevant in Laos and some examples that may be relevant in the United States or outside of Laos or for everywhere. This overall aim is to test the efficacy of a lifestyle intervention to reduce risk factors for type 2 diabetes and hypertension among school-age children with history of obesity. In specific aim 1, evaluate the impact of the lifestyle intervention on the biomarkers of insulin resistance among school-age children with a history of obesity. Hypothesis 1 goes on to define what those biomarkers are and what they expect to find in children randomized to the intervention versus the children in a control group. The exposure and the outcome are well defined, as is the expected relationship between them. The second specific aim is essentially the same, it's similar, but defines the biomarkers for hypertension rather than insulin resistance. You can see that you can still conduct aim 2 if aim 1 fails, and you can conduct aim 1 even if aim 2 fails. The aims are not interdependent. When you're writing the significance and innovation section of a grant proposal, the significance is fundamental to address how scientific knowledge, technical capability, and/or clinical practice will be improved if the aims are achieved. So what is the significance of the study on a public health problem? How does it address the gap in knowledge? Innovation refers to what may be unique about the approach or solution that your study proposes. Are you using a novel theoretical concept? An interesting or innovative methodology? Is this a new intervention? Or are you adapting an intervention in a new population? Are you improving methods or interventions in the area? Innovation describes what's unique and different about your study that may make it more likely to find a solution than previous studies. In summary, the steps of identifying research aims and developing hypotheses are embedded in this non-linear, flexible approach to research. You may draft specific aims and then realize as you're exploring the methodological approaches that you have to make changes to your hypotheses. As long as your aims and hypotheses are rooted in the existing literature, supported by evidence, justified by scarcity in literature, are written clearly and concisely, and easily represent the impact that your study will have on public health, you're in good shape to begin. And here's a practice exercise for you. Imagine that you've been asked to develop a study based on the mixed data set. You've conducted a thorough literature review, and based on your research interests, you want to study breastfeeding and growth and development in children. You have access to these following variables. What are a possible set of aims and hypotheses that you could create for a study? If you can, take a few moments for yourself and write an overall aim, 2 specific aims, and 1 hypothesis for each specific aim. Discuss your specific aims with others if you're able to do so. And there are a range of possibilities here, and there are many good possibilities and answers. Thank you. If you have any questions, please let us know, and we'd love to hear your feedback on how to improve.